Yeah, hi. Good evening, everyone. Sorry. Am I audible? Hello.
Yes, sir, you're.
Yes, sir.
Okay. Okay. So, as this is week 3 doubt session, we have already done the two sessions for week 3. I think before the paradox. So that open session and live coding session have already done. So we have scheduled this session only for the doubts. If you have any doubts till now, till week 3, so you can ask in this session. Okay, we are not summarizing or not recapping all the things, but if you have any specific doubt, any difficulty to understand any topics, so here today you can ask.
Yeah. So, sir,
So you
can
you
we
can
move
raise the
forward?
hand. You can raise the hand. Okay, those who have any query, you can raise the hand. Then I'll take the query one by one. And one more announcement that we have sent the announcement message also. Let me share. Okay, I hope my screen is visible. So, for week 2, actually, we have received many requests for the week 2 assignments. Many of them actually missed the week 2 GRPS, and this time OPP rating criteria is you have to score at least 40 marks in every week GRPA from week 2. So, so we have released the additional week GRPA for week 2 only. Okay, so you can see this label, new GRPA 1 only for week 2 OPP eligibility criteria. So week 2 score will be not calculated based on this new GRPA. So these three assignments we have released only for the week, just fulfill week 2 OPP eligibility criteria. If anyone have missed before. Okay, so now you can attempt this. The deadline for these assignments are 25 June. Okay, so complete this before the deadline. We will not extend this deadline further. Also, from week 3 onwards, we will not accept this type of request. So this is only for week 2 we have accepted.
Not
Okay.
necessary for people who already attempted, right?
Those who have already attempted these previous GRPAs of the week 2, and they have cleared the criteria of OPP. Okay, no need to attempt this. Those who have actually not fulfilled the criteria or completely missed these assignment of week 2 GRPA, they can attempt this to just fulfill the OPP eligibility
Sir,
criteria.
when will be the OPP exam?
OPP exam will be conducted after quiz 2. And I think date is given in the grading document. So I am not sure you have not checked grading policy. Some dates are mentioned already. And term programming exam. You can see 17th August. This is the date. But this is the one date. But I think this exam is conducted in three shift. So maybe 17 and 1 week after that. So total three
Well,
shift this exam generally
sir,
conducted.
in scenario where we have got below 40, will it hamper our execution to the next program?
No, below 40 means in OPP exam you are asking?
Yes, yes, sir. Yes, sir.
No, there is no separate passing criteria for the PDSA OPP. Okay, so how much any marks which you are getting, if you are suppose if you are completely absent in the OPP, you will lost your 20 marks in the final score, but you will not be failed.
Sir, sir, sir,
Hmm. Yeah.
sir, I'm having OPP on 16th for system command and 17th for PDSA, sir. So one
Huh,
day
so
it's very difficult, sir, to prepare both
no,
like that.
you have one day in between. Otherwise, many of the students will give the exam on same day, 3 OPP or 2 OPP. You have to here
So
you have to prepare before the exam for all courses, not only for, just not to not keep one day for the preparation. Okay, so these schedules 17, there will be multiple OPP exam like DVMA, system command, PDSA, or Java, or all diploma level courses, and maybe some ML side courses also. So they will plan in this way, so you will not get conflict at any one time. But there is a chance you have to give the exam on same day, 2 or 3 exam OPP. Okay, so because these exams are only conducting on Saturday and Sunday, so we cannot give any another date like weekday we cannot conduct. Okay, but there is no separate passing criteria for this PDSA course. You can there is no passing pressure for this exam. So just attempt this exam and try to solve maximum number of problems and score maximum marks in this out of 20.
Sir,
Yeah, Kiran.
mm, sir, what if I submit both new and old GRPs? Which one will be evaluated?
As I mentioned that this new assignment will only be considered for OPP eligibility criteria checking. So suppose if you submit the new one also, still that we will check which assignment, older one and newer one, which assignment you are satisfying the OPP criteria, we will consider that. If you
The
are
best one, no?
fulfilling best one, we will just consider. But that these new assignment will not affect your beak marks, beak 2 marks. That will be that will be calculated based on the older GRPS. So if anyone missed, they will get 0 marks for GRPS. So we have sent the announcement for this. You can read the announcement. All things are mentioned for this. You can see the rule. So all details are mentioned that these new GRPA will not be affect the weekly score, your week 2 score.
Sir,
Okay,
we
this
have
will be
covered
only.
week 3.
Huh? You have
We have
covered?
fully covered the week 3 part.
Yes, so we have already done week 3 live session before this month. So we have covered all the content. But if you have any doubt in any topics, you can ask today. This Friday we will not conduct any live coding session because that is already done for week 3. From next week onward, we will continue the week 4 content because week 4 content will be released on this Friday. Okay.
I have doubt in week 3, the
Hmm.
coding session.
Coding session.
So for, what if I missed the live coding session, sir?
So all recordings are there, no? So that live session details are there. Live session details we have mentioned. There is one seat, current instructor live session seat. You can see all the big 3 live sessions are conducted. So you can see YouTube links are there. You can watch.
Sir, where are these best live recordings?
No, there is no best live recording. That was the plan when we are not conduct. We have decided to not record this session. So we plan to release the best live session for previous terms, but now
Mhm.
recordings are there, so we are not releasing.
Okay, okay.
But all previous terms, the recordings are available on the YouTube channel. You can watch previous session also.
Yes, sir.
But this terms, these 3 weeks are covered, so all recordings are available in this sheet, which we have already mentioned in the portal. Okay, course
Sir,
live session
hello.
inside. Huh.
Previous TS session are available anywhere.
Previous what session?
Previous TA recording session.
So current TA session recording is also available. Now, why you are looking for previous term TA session? Current term TA live session recordings. We are maintaining this sheet. You can see all drive links are available here.
Sir, but this is not for DBMS and the other course. The like PDSA was fine, but DBMS and MLF, I'm not able to see that.
TA session recording.
Yeah, in the current session recordings, I'm getting on live session details. We are getting only the best recordings, I think. For the like PDSA, I have like confirmed that we are getting the current session recordings. But for MLF,
Now every course is providing the current current recordings. recording. I think you can check on the channel, DBMS course channel, a YouTube channel, and you will see all the recordings are will be there in the live tab. Okay, so just like here, every course has a course channel. That course channel YouTube page. So this is the one link, like PDSA. So this is, so you can see this is our PDSA channel. Similarly, we have all course channel. So you can just click on this live button, and you can see the all previous week session. So here week 3, week 2, all sessions are here. TA sessions are not YouTube streamed. You can see the recordings in Drive. So we are maintaining one seat for that. Maybe other course are maintaining in different way, but you can check with the course instructors how they are actually maintaining. Otherwise, in calendar also you can see the recording. So suppose if TA session was yesterday, so the 17th, this was the TA session. So after session, you can see the recording is available in the same event. So yesterday TA session, you can see PDSA TA session recording is here, so you can watch that. So every TA session link, this event, you can see the recording. Okay. So and instructor session are available on YouTube. Yeah, yeah, Kiran, go ahead.
So, sir, can we do coding also in this session?
Coding. Okay. So which week you are talking about? The week
Talking about the current week only. So,
week 3 live coding.
the
Yes.
lecture content is very limited, no? Mm. Uh, The
Mm,
W linked list was not explained in the lecture, but we all learned and implemented it also. And in the PPA, there is hashing based question.
mm-hmm.
Um, we didn't learn how to implement it. Can you explain hashing implementation?
Okay. Yeah. Okay. I'll explain. Yeah. Another Salini. What your doubt?
Yeah, sir. I also had similar doubt, but I have one question, sir. We did a selection sort, insertion sort, all that. In the activity, we get those questions, no, sir. How many comparisons? How many shifts?
Mm.
Is there any simple? Because I put the algorithm. I mean, I work the each list and then come up like 15 shifts or swaps, 15 comparisons, iterations. Is there any simple way to achieve, I mean, get that number, sir, for
No,
each?
in activity, we intentionally giving this type of questions. So at least you can try some dry run on the algorithm.
Oh,
What
that's
have,
all. So is there
huh,
any formula to remember or?
no, no, actually, there is no exact formula we cannot use. That will not always, that is totally depends on the implementation first.
Okay, so we have to
Okay.
run that algorithm. Is that correct? So that
Huh. Not
oh,
run the code like this. So we have given the algorithm pseudocode type of things.
yeah, yeah. So I have to
So
run.
we actually want that
Ah,
you apply the dry run. Dry run means
ah,
just do the steps by on the paper and pen and
yeah, yeah.
check what
That's
steps
how
are
I did.
going on.
Okay. Okay, I got it.
And that is actually we are giving intentionally. So at least you should understand the steps of the algorithm
Okay.
by
So
solving
okay.
these questions.
So I get the list, then I put through the algorithm, then I arrive
Hmm.
that. That means that is the correct approach. Okay.
Yes.
Okay. Okay.
So just
Thank you.
first understand the steps of algorithm by looking the pseudocode.
Mm.
After that, follow that steps on the inputs which we are giving as a list, and see how the algorithms are sorting the list, how the comparisons are happening, how the swaps are happening.
Mm.
So all these things you just observe and then identify the answer.
Okay. Got it, sir. Okay. So there is no
Okay.
formula or any
No,
like
no,
yes.
these are not formula based questions. These are implementation based questions to understand the algorithm.
Okay. Okay. Thank you, sir.
Yeah, some like we will see some formula in graph where graph properties related things. There are some standard formula that we will discuss. Some questions you will see in the week 4 where we can directly apply the formula. So that are actually predefined properties of the graphs. So
Mm.
that learn what are the formulas we have. But here
Oh,
for pseudocode or implementation related questions, so there is no any specific formula.
okay. Thank you, sir.
Okay. Okay. Any other query in chat?
Yes,
PTS.
hello.
Yeah. Yeah, Basant.
Sir, in placement activity point, I opened the sheet of PDSA, the 20 easy level question open in lead code, then one question showing another 19 question where I can find, sir. I try, but which one to
So placement activity questions. So some like quantities given like 20 easy level, 20 medium level, 10 hard level, like this type of. So what you can do, you
yes,
can just make a profile on the lead code, and here on the lead code there you can just filter the question based on the topics and based on the difficulty level. Okay, and solve these
yes.
questions. They will just
And,
solve the easy level, then medium level, like this, and that profile, you will get all the information how many questions you have solved level wise. You will get all the information on your profile at the time of placement. For like placement activity, they will ask to submit your profile image or profile picture. Okay, at that time you have to share your profile, that lead code profile page. Okay, so they will just validate that you have done some coding to fulfill your PDSA activity, placement activity
Sir,
points. Hmm.
sir,
Sir,
can
Yeah,
you
yeah,
PPA one?
Ganesh first. One
uh,
second, Ganesh. Yeah, Ganesh, go ahead.
yes, sir. Sir, I have a doubt in this week 3 content. Let me ask that one.
Okay. Yeah, what
Yeah,
allowed?
so sir, my doubt is, yeah. So in that GitHub notes, and actually it
Hmm.
is in lecture code also. So the code is Python code related to linked list. So
Hmm.
uh, yes, sir.
Linked list. Okay.
So in that linked list code, whatever the professor is explaining in that slide, no, that code
Hmm.
in that
Hmm.
delete function
Hmm.
in the recursive part.
Hmm.
So, yes, sir, this one. So I understand, but the last else statement, if self dot next is not equal to none, then he is going to delete. He is just recursively called the next node to delete. So
Hmm.
I understand from that point, and I don't know what is that if statement is actually doing in that here. Like after that self dot next dot delete, there is a if statement to make that self dot next is none. So that is very confusing, sir.
Okay, so if you are not able to figure out that what is the purpose of this part, okay, so why you are not trying to write your implementation for this?
Yeah, actually, I tried to write
So
my.
I'm not saying that this code is all these codes which professor have used and which we have also added from our sites, all are 100% accurate or all these things. There may be a chance that some small mistakes or some small mistakes will be there, because maybe some additional steps, maybe some unusable steps may be there. Okay, so these are giving as a to perform some tasks. So if is there any problem with this additional lines, if you are not able to understand, if you will remove this, what effect is there in the code? Did you
Uh,
check that?
Actually, I tried with some examples, sir, but I don't know which is the corner case that is going to cover that
Huh.
step, because I don't know like what is actually that step is doing. That is my problem. If I know, okay, that step is covering the corner cases, then I can create that corner case problem, and I can
So
run.
there, okay, so there is a chance that this is just like a unused type of code. Okay, there is a possibility also. If
Oh,
you are thinking that this there is no use of this part,
hmm.
correct? This part you are talking about now.
Yes, yes, sir.
Hmm. So I have to actually I have to also check line by line complete implementation, then I can directly come up this. Okay, because I also not remembering that what is this actual code, so I have to check this. But
Okay.
there is a chance that maybe some part of the code is you will see also in coming week, like week graph algorithms, you will also see some part of the code maybe that is not required. So there is a chance, but that is just like a we are just trying to implement something, and this is the implementation of one person. The
Hmm.
same task can be done by different implementation also. So
Okay.
we always said that if you understand the concept of operations, like how the insertion is performing, how the deletion is performing, so you should try by your own code.
Okay, sir. Okay, sir.
Okay, so like this second implementation is given, yeah, for the same thing. I think this one, this is also the for the same thing. Okay, but
Yeah.
this is the totally different implementation. If you will see any another resource on the internet or any another resource on any book, you will see always the different type of implementation. So why you are focusing too much in one of the implementation?
Okay. Got it, sir. Yeah.
Okay,
Uh,
so just try to just first understand that how the that operation is performing, and then just write your own code. Okay, so that will help you to learn the code or implementation or algorithm very well. You will always remember your code, what
okay, sir.
approach you take. Okay,
Okay.
if you try to learn any another person code, definitely you cannot remember, you will forget that
Hmm.
when you will
Yes.
require it again.
Yes, sir.
So
And
for uh,
yeah.
because this course contains at least I think 40-50 algorithms. How you can remember any code? Nobody can remember any code.
Right. Yes, sir. And I have a like in that same logic, in the same linked list. So when we are trying to insert a head node, so we have already the linked list is there. So we are trying to add the new node as a head. So that time, why like the professor is explaining like we have to exchange the values, then we have to connect the references accordingly. I don't know. I didn't understand why he is exchanging the value, then he is connecting that head node exactly, sir.
Here actually that head node. So that is recursive implementation. This object. Okay, so this is a one class we are using. Okay, in the same class we are calling the methods. So when we are creating the first object for this, like this head equal to node 10. Okay,
Right.
so one instance is created for this class.
Hmm. Yes, sir.
Okay, if so one instance is created and that instance is also containing the value of first node.
Yes.
Okay, so that means head itself a node here also. Okay, so let's understand that. So here what is that head actually had also a node actually. Okay, so that contains the value, like if we are storing 10 and that contains the next node address like this. The general implementation we consider like this. So head we have one variable or something that contains the different memory location that is represented as a first node. But this recursive implementation, this is actually a node. Okay, and that is also referring to the head and first node, and also referring to the head. So this space okay, this space contains the value also and also referring to the head value. Here these both are the separate things.
Okay.
Okay, and any function. So if we are trying to add one more elements from this, so what we are trying to do, we are just entering into this instance, and we are calling the method for method insert method from this instance, head instance.
Hmm.
Okay, then we can only add. We are adding the second element. Always what we will do, always we will always insert this instance, and then recursively we will move to the second instance, then recursively we will move to the third instance like this. Okay, so this is just like a object, we are entering into the object because this is a recursive type of implementation with the help of one class. Okay, so every operation is happening by using some object that itself is also reflecting a node value. We cannot directly call this node, and we cannot directly use this method of with the help of this node. We will always enter into this instance recursively, we will call second, then recursively we will call third. Okay, so always we are coming from this side. Suppose if you want to delete this first node, you will lost all the connections.
Correct.
Okay, so if you want to delete this node, first node value, so that data, that is the first node where from we are entering this operation. Okay, if you will delete this, all connection will be removed. You will lost all the like connection, because you have created some node like an ODE, and that is just like a object. This is the first object. Okay, if you delete this, you cannot call the methods for this to update this, because you have just deleted the entry point.
Yes,
So
sir.
because of that we are not deleting this. What we are doing, we are just updating the value like this, and then we are removing this part. We are doing this type of operation.
Okay.
Sir,
We are swapping the values.
sir, how do computer handle this deleted value nodes? Will it store it in some temp files or will it delete it permanently?
No, that is managed by the language Python interpreter. If you have removed the link, so that will by default like dumped actually. That
Dump.
is managed by the so if any like if you're not using any part, this will not be deleted. Okay, so if you have removed this, you will lose the connection. You cannot recover that. You don't have pointer concept or address concept in Python language, so you cannot. But that will be managed by the Python. So if you're not using any memory location, after some times or after your program completion, that area will be actually released.
Okay, sir. Sir, then I have a doubt in
This
that.
second implementation is easy to understand, because here head, this is the totally separate memory area. This is just like a variable that is placed any other place. Now we are storing the address of this first node inside this first node head. Okay, so like head is just a name of the memory location like this, and we are storing the address of the first or reference of the first node here. So like suppose if this 1000 is the reference, suppose, so 1000 is stored here. So now this is link. If you want to remove first node, suppose this second is 2000. So what we will do, we will just update this value here. So we will update this 2000 here. So now connection will be logically like this. So this is all objects are different objects. Okay, so second implementation is implemented like this. First implemented, which professor have used, that is recursively, because to perform the recursive operation we have to always enter from the first object.
Okay.
Okay, so we cannot delete that object.
Yes, sir. So how we get to know like head is attached with that first node or head is separate? Head is
So
a
in
reference for that first.
implementation you can see the implementation and just understand that how the like in details are given. Okay, so any operation are not affected by this different implementation. Conceptually what we have, this type of structure, we are just learning this head is there. So head is just referring to the first node.
Hmm.
Okay, like this in this list. So this is the structure of singly linked list. How you can implement this structure, that is up to you.
Okay.
Okay,
Yes, sir.
so that should be fulfilled. And this is the first node, this is the last node. Notification of the last node is the next field should be null. So this is the termination point of this list. So in this way you have this structure. Now you can traverse the list, you can delete the elements, insert the element at first position, like all basic operation which we can perform with the list, you can do this. Okay,
Yes, sir.
so this
Uh,
is the standard structure. Just try to implement by your own. This is just a memory space. Okay, that contains two fields, one for data, one for reference of next node. So
right.
this we are creating with the help of one class. Okay, this is just like a object that contains two members, data members and next field member, and we are storing that data in next reference and connecting this list.
Okay, sir.
Okay.
Yes, sir. Sir,
Huh.
so my next doubt is related to that closed hashing. Sorry, which one that closed addressing means open hashing.
Hmm.
So yes, sir. So from my understanding, so we have a dictionary. So we are taking the key and use the hash
Hmm.
function. We are
Hmm.
encoding that whatever the key we have into the index 0 to something. So that I understood. But here each block is connected to some kind of linked list format.
Linked list,
So,
yes.
yeah. So, for example, 10, 20, 30, it's mod 10, then all is coming like this 40, 60, 70. So, if I'm trying to access the 10th, like in my, like what I'm trying to say is, I want to access the key of, let's say, 40 or 60.
Hmm.
So, that time it will encoded, sorry, it will decoded and come to the zeroth index. But the zeroth index is actually a list of elements. So how it will return the proper element that I am asking.
So then you have to traverse the linked list, and then you have to match the element. You have to
uh,
compare the elements.
Sir, but for example, my name is Ganesh colon. I have maybe some marks like 90 or 95. So
Huh.
there is some person with my same name, and they are getting the different marks, 80 something or 100. So
Hmm.
uh, to use the hash function for my name, you will get the zeroth index. So the person is coming and okay, Ganesh or Ganesh one, because two different thing we are getting the same index. So that is a concept. So for that person, they want to get their marks, but in that list, my marks is also present. So how the
Huh.
program will identify? Oh, a lot of numbers I can traverse and I can get, but which one is proper to that key?
Okay, so then for that, actually you have to store for this type of like scenario which you have mentioned, where some identification is required for each item separately, like marks you said. Definitely you have to store some that identity for that to maintain some unit. Otherwise,
Okay.
if we are just storing the data like this
Mm.
40, so there is a chance that this 40 will come again and again like this. So that maybe store multiple times. So there is no identification for that which you are looking for. That you have to store some additional information to identify that.
So
Hmm.
so the question is not that. The question is we have that hash function from which we'll get the index of the bucket. Now we go to that bucket and we are seeking that value. But in that bucket we have a list of values. So which will be returned to us? That is the question.
So if value are same, that if
Like
it
for
is
example, at zeroth position we have
hmm,
40, 60, and 70. Now if I seek a value which whose hash value is 0, so which one will be returned to me, 40, 60, or 70?
no, what you are saying, this is just a storage. Okay, this is just a
Correct.
storage.
Yeah, this is
Uh,
internally stored in a hash table.
Stable. So you are
Okay, this
saying
is,
that you are just maintaining a dictionary type of data where
yeah,
you are
I
maintaining
in the
key and
hash
value.
table I give the key
Huh, huh.
for which the hash value is
Okay, okay,
coming
I'm
out to be
getting your
0.
point. You are just relating this structure to dictionary type of things. Okay.
Yes, yes, yes.
So dictionary is just a like one application for this hashing. So at that time, key and value both will be stored in the each linked list part.
Okay. Yes,
Okay,
sir.
so
If
we
key
will
and
also store the key. We will also store the key with value.
right, then we can iterate and we can find,
Huh.
oh, for this key we will
Yes.
get we will take this value. Yeah.
Yes. So at that time, so this is just a that collision resolution techniques actually. Okay. That if you want to use this as a dictionary type of format, dictionary type of structure, so that key value you should also store.
Yes, sir. Sir, when we are using this hash table, like this hash index, so we are doing the linear prop. So my doubt is like my data is in the last position. Maybe there is some empty spaces before that last position.
Mhm.
So that linear probe is going circular to the starting and again searching linearly.
Yes. So linear probing is checked that each place one by one. Okay. So suppose like we have this type of box. Uh, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, suppose we have the 10 as a like divider for this remainder part. Okay, so suppose we are jumping all these places are fulfilled, okay, and our data is not matched here, and suppose we are giving 33 by 10 and we are getting remainder 3 and we are jumping directly first here. Okay, and at the storing time our data 33, all these data were was already filled, and our final data this 33 is stored here, because this is just like a circulation. So what we actually
Okay.
does, so how many we that locations we have, total 10 locations we have. Okay, so first we checks the first location which we are getting, so 3 reminder we are getting, then we add 3 plus 1, and that remind divide by 2, so we will get 4 4 location. Okay, so in this way we will linearly increase. So what is the this value which we are increasing? So this is just a I value which will run from 1 to like 9 or 10, these things. So every time we will add one value, so 3 plus 1, then we will calculate, then 3 plus 2, then we will calculate 3 plus 3, and then we will calculate. So in this way, once you will get 3 plus 7 and this reminder 10, you will get 0 reminders. So that means you will check this location. So we will
Okay.
check all possible locations. So if you are starting from here, you will check this side, and after reaching to the last location, if anything is remaining, so you will come this side. Okay, then you will check all these the remaining locations.
Okay, sir.
So
Sir,
in this
and
way,
I
linearly. Hmm.
Yeah. Sir, I have a general doubt. When I am seeing that actually Python list implementation underlying is an array. So when professor is saying, okay, we have array, so we have some memory. So if all are integers, then easily we can go to that particular indexes doing some arithmetic calculation. That I understood, sir. But Python list is actually it's a dynamic, like we can attach any data type to that. So if I'm attaching int, maybe it is a 4 byte string, it is a big string, or it is a dictionary, so anything I can append to that list. Then how would that arithmetic calculation will be calculated and getting that particular element in order of one time?
Okay. So in array implementation, you know that in other language like Java, C, we can store only one type of element that inside the array. Okay, so
Yes.
if we are maintaining like integers, so we can store only integer elements. So that actually allocation will happen only the compile time, at the compile time, and what memory we are allocating. Like we are allocating 10 size, so 10 element memory will be allocated here at the compile time. We cannot release the space of this array, or we cannot also increase the space at the runtime. So here list is different. Okay, so list actually maintain the index array totally separately. Okay, so that is just like maintain a dictionary type of mapping. Okay, suppose some memory location continuously are allocated, but this index part, this mapping part is managed separately. So like
Okay.
zero index, okay, so that will be mapped to the first location. Okay, and that this one index, this will be mapped to the second location. Suppose by default I think 4 memory location, or say 8 blocks is assigned when we initialize the that list in Python. Suppose
Oh.
at the time of initialization L equal to created empty list. So at the time, I think 4 or maybe 8 blocks is assigned continuous memory locations. Okay. Once we will fill this 1, 2, 3, 4. Okay. So all blocks are filled. So 1, 2, 3, 4. Now, if we want to append one more element 5,
Hmm.
at that time it actually double the space. It will provide the same space again. Now
Okay.
this will be mapped to, so this indexing table is totally separate, so that is actually is a continuous memory location, and at the time this allocation is happening like this. Okay, so this indexing will be just like a mapping, dictionary mapping things with 2, 3, 4 like this. So
Got it.
you get the data from this table, not the direct this
Yeah,
memory
yeah.
location.
Yes,
Okay,
sir.
so this type of architecture is maintained.
Okay,
Okay.
sir. Thank you, sir.
Okay, yeah. Any other query? Other, yeah. So PS Kiran, you mentioned about the doubly linked list type of things. Now you are facing the issue in doubly linked list.
Yeah, so doubly linked list is fine. Can you explain the hashing implementation?
Implementation you are asking? Okay. So where we use the implementation? Any I think in any question, no? Big three.
PPA 2.
So one question is asked for this hashing table. Okay.
Yeah, sir, that will try. But can you explain the
First thing
hashing?
is your concept should be clear for the hashing things. Okay,
Yeah,
so
concept is clear.
we have some. So here I think quadratic probing is given. So quadratic probing is checked like this. We checked first h. Okay, h is simply is calculated by k mod m, like what formula hash function we are using. After that we use k plus I. Okay, so I or we use the formula I square. I think formula is given here. So hk plus c1I plus c2I. So this formula is given for this quadratic probing. So here just pass I equal to 0, I equal to 1, I equal to 2. Okay, so this is just like a formula is given to you. Total memory space are also mentioned in the problem. So what all these value are given, you can see c1 value is given, c2 value is given, m value is given as a sample input, and data is given. So all information you have like for this formula which we are using hk. Hk is what? Hk is simple k mod m. Okay, so k mod m, which so k is here data actually. K is a key. So if you see, if you understand this, so we are using this is just like a explaining things, and you need to implement this. So here some formula is given hk equal to h. Okay, so let me check once again. Hmm. So hki. Okay, so hk comma I is given hk plus c1I plus c2I square. Okay, this is formula is given, and I value you need to maintain this 0 comma 1 comma 2 till m. How many locations we have? Okay, total locations we are available. So that is given here. So m minus 1. So we are starting from 0. Instead of that we are using m minus 1. So every time, so m value is given here like as a third input. Okay, 11 is given, and same we will use for k mod m, and k value is given in the list. So okay, what we are doing? Okay, so one second. Okay, so for to solve this problem, just do not think about like any hashing or these things. You are given one formula. This formula is given to you. All value are also given. For c1 value is given in the formula as input, and you put the that value c1 and c2. That okay. Suppose if we are putting c1 equal to 1, c2 equal to 1, so this formula is become simply hk plus 1 into I. Okay, so that c1I, so that become a I, plus c2 is also 1, so that is become I square. And this hk is simply a formula like k mod m. Okay, so k reminder m, like this.
So
So
how
just
do you get C1 and C2?
so that is given in the input, no question statement. You can see what we are giving the sample input. First value is representing c1. Okay, c2 value is given as a second input. Third value is m. All this last value is all data actually, which we will insert into the hash table one by one. 22 first, then 2044. So let me take this and show you. So how this problem is solving? We are solving. So just see this sample. Should I square? Okay. Okay, so here just understand that these inputs you are getting as a input for the program. Okay, now you are using the formula like this h. You can take any variable. This is just a formula representation for quadratic probing. So h k comma I. You can give any variable name for this equal to k mod. Mod is just this reminder syntax, and that m value we are also getting. Okay, so this m value we are also getting plus C1 into I plus C2 into I square. Okay, so this is just a one expression. You are getting this list 22. So 22 come first. Okay, and now first, what is the first step actually you have to do? So you need to create one list. Okay, none. Just take this one value none and multiply with what is the size m. Okay, so this list we have created. This is the initial list. What is the size we are creating here for the what is the size for hash table? So here size is given 11. So that means by default this list will contain like all none. So none means absence of value. So none like this. This is just a initialization. Okay, like all 11 value. Okay, so 0, 1, 2, 3 till 10 index. So this is just a initialization for list, and we are considering this is a hash table. Okay, after that what we are doing, we are just reading all value one by one. So this is just a simple a Python list. We have initialized with all value none. Now we will take 22. This is the first k, 22. Just pass this value to in this formula and all c1 c2 all this in this formula, and calculate what value you are getting for first I. Okay, and this should be written inside the for loop for I. Okay, so I should be 0 to I minus 1. This should be the loop. Okay, and for inside this loop, always check. So what value you are getting for what index you are getting by this formula. If that index, if the value is none, then store your data. If value is not none, then further move to this loop and check for the next value of I. Okay, so just understand this. So 0 k equal to 22. What is the what value you will get for 0? So we are just putting I equal to 0 in this formula, and c1 is 1 and c2 is 1. So k, when I equal to 0, what h 22 comma 0 you are getting? So this is just like an index we are calculating. Okay, so what value you will get? So k is equal to 22, remainder m is 11, plus c1 is 1, 1 into 0, plus c2 is 1, 1 into 0 again. Okay, so this expression will be calculated like this. And what remainder you will get here by this? Tell me, what value will come by this expression?
0.
0.
0. Okay, so 0, now we got this value as a index. Now we will check at this index in our array what is the value actually. Okay, if this index of L of this 0 index is equal to none, so that means our hash table at this place is empty right now. So we will store this 22 at this index. Okay, so L0 at equal to 22. So we will check this condition. If this condition is satisfied, we will store our data. If this condition is not satisfied, okay, or after this checking, we will also stop or break this loop. Okay, we will break this loop in our implementation if our data is stored at empty place. But if this condition is not satisfied, then we will continue our loop and we will check for I equal to 1. Okay, so in this way, you can see in the first checking, this 22 is stored like I am just maintaining here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now 22 value is stored here. Okay, now we will check for 44. Okay, so 44. So again, we will use this formula. So for k equal to 44. Okay, and now again we will start the loop from same value 0 and check. Now 44 remainder 11 plus I is equal to 0. So again all values become 0, the remaining part. So what value you are getting? Again 0 index you are getting. But this time at 0 index none is not there. Okay, so the value is there 22. So we will continue our loop. Now we will check for I equal to 1. So same 44, this 11 plus C1 I square. So C1 is 1 and I square also will become 1. So this is 1 plus C2 is C2 into I. So this was C1 into I, not I square, sorry. C2 into I square. So that will also become 1. Okay, so in this way, now you are getting 0 plus 1 equal to 2. Now you are getting second index. So that means this is not a linear probing, this is a quadratic probing. So by using this formula, so we will directly check the second index now. So second index value is none or any other value. So if it is none, we will store our data here 44. Okay, now third value is 35. So 35, again we will start the same thing. So I equal to 35, and we will start from I equal to 0. Now 35 remainder 11 plus 0 plus 0. So what value we are getting? 2. Now 2 index already value is there again. So then we will check for I equal to 1. So now 35, uh, this 11 plus uh, this I square. Okay, so this will become 1 plus 1 again. Okay, so 2. Just add, so this is 2 plus 1 4. Now check the fourth position. So this here, this is none, so 35 will store. So we are just doing the hash concept with the help of simple Python logics or simple one formula. So this is just like a simple logic, and we are fulfilling our hashing concept with the help of this. Okay, so you can see we are maintaining this. You can see in the output, 22 is stored at first place, 44 is stored at second index, 2 index, 35 is stored at fourth index. So in this way, our data is stored by using this formula. So you need to just convert this concept into your coding. So I think you can do simply. You can make a function. What you can do, you can just, this list you can maintain as an initial list, and after that read all data one by one, or you can make separate function for this loop part. Okay, this loop part, what we are doing. And at any time, if our data is stored, this condition is satisfied. If our data is equal this point, okay, this index is equal to none, at that time you can stop the data and break your loop, and okay, your data will be stored at the correct place. So in this way you can perform the implementation, how the hashing is actually works. Can you try this after I think this concept is clear to you, this problem? Because I've mentioned all the part, initialization part is required when all lists should be initialized by none. After that, for each element in the input list data, okay, just run a loop for I equal to 0 to m minus 1, and just calculate the index by this formula, hash formula, which is given in the question, and check the calculated index is filled by none or not. If it is filled by none, then store your data. Otherwise, just continue your loop for the next empty location. This is the only logic part for this question.
Sir, the loop will run for how much iterations, sir? How to
0
decide
to
that?
0 to m minus 1.
Okay.
Okay, loop we are running for I equal to 0 to m minus 1. Okay, but at any point, if our location is empty means none is stored at that location, then we will store the data and we'll break the loop. No need to check, because our data is stored, no need to check the remaining part.
Sir, it may happen that we start filling the value from the middle and we go till the end, but the initial part is empty. So
So
wouldn't it?
by this formula, you will automatically come to the initial index.
Okay, okay.
Okay,
Because
okay.
it is
This
mod
is the
operation.
reminder. This is the mode operation, na?
Okay, okay.
So you will come to the that part. Oh, okay. So in formula, I think there is one more mod. I think. Let me check. So you can see we missed this the remaining mod part. Okay,
Okay, sir,
yeah.
got it.
So we will also use inside the formula. We will also apply the mod here to fulfill this part. M. Okay. This. So in this way, you will get like what is the value for this, and then you will add this I value, and then again you will calculate the mod M. So in this way, you will get a if you are reached at the last location, you will come to the initial location after that. Okay. I hope this Kiran, is it clear?
Yes, sir. Concept is clear, but
Uh-huh.
That's
So
some problem.
implementation after if concept is clear, then implementation is just like a simple Python
Mhm.
problem.
Mhm.
Okay, just just consider that one formula is given. You are filling your list. You're calculating index at every time and filling your list. This is simple, just like a simple problem. Do not use the terms quadratic solving. Do not worry about these terms. You are simply solving some basic problem. Okay, so I hope you can try this. Sir, could you please share PDF notes of PDSA? PDF notes. What this is? PDF notes are the same which we have released in the GitHub notebook. This is the same notes we have PDF. You can also download these paste as a PDF. We are not using any another PDF notes. We are using the same PDF notes.
Sir, how can we download it?
I think you can simply print that page. What information is coming? I'm not sure. Oh, complete page is not coming. Okay. So yeah, you cannot download it. I'm not sure. Or that GitHub, no, this you can just look this GitHub repo and you can see all the separate page. Okay, so this is uploaded on the GitHub. You can download the page. Separate files are there. Like 1 second, PDSA GitHub. So this one. So you can see all beaks. These contents are there. So beak one, you can download all the page like beak one HTML, so that you can download by this GitHub. Okay, so this is the link for GitHub. This is public, and you can download and make as a PDF. Basant, your mic is off. I think. Okay, I'm sharing
Sir,
this in the chat.
hello.
Hello. Yeah.
Can you go through GRPA 3?
Sorry, Basant, what you are saying?
Uh, so I have problem with GRPA 3. Can
Week
you?
three.
Yes,
Week
with
three,
3
you're
GRPA.
talking.
Yes, sir.
Okay. This is week three. Hmm.
Yes.
Okay. Complete the below function reverse route. The that will reverse the linked list with the first node passed as an argument and will return the first node of the reverse list. Each node in the linked list is an object of class node. Okay, so I'm just telling you the concept. Okay, this is just like a linked list. Okay, where the value each this all these fields containing the data like value is storing value, next is storing the reference of next node, is empty is the method you can check the list is empty or not. Okay, now in this function how you can perform this task. Suppose if you have list. Okay, first node, I'm just assuming that this is a head and this is containing like a one list that may contain any number of data, but the direction of this list is just like a first node to last node. How you can make this reverse, and this is the identification as a null. Okay, none or none in Python, null in C. So like 10, 20, 30, 40, 50. Okay, so this head value is passing to inside the function as a parameter. That means that is the information content for first node. How you can reverse this and how you can pass return the first node reference of the reverse. So what you can do, you can make two pointer. I'm just giving the logic idea. You can make it two pointer, so you have the head information in the as a parameter in the function. Okay, so head represent the first node. So you can just write like a temp one equal to head. So this is the that means you have just assigned one temp one to first node. Okay, now what you can do, I think you have to maintain maybe three for this. So let me just check this. And you can also maintain temp 2 equal to temp 1 dot next. So temp 1 is referring to first node head. Now temp 1 dot next, so this next value is referring to the second node. So temp 2 will come at this point, temp 2. Okay, so this is just a initialization point here. And from here what we can do, how you can reverse this list. So for reverse this list, just reverse the direction of your connection. So that means the node first node 10 value. Okay, so I'm just taking the name with value. So 10 node, this 10 value node contains the reference of 20. Okay, so what you can do, you can just change the address of the storage area. So what you can do, you can just store the address of this node, okay, into this place. So this will be linked to this and make this null.
Yes.
Okay, and just keep maintain your variables after performing this operation. You should not lose the uh, further node address. Once you will update the address of 20 node to the first node, this connection will break actually. Okay, you will lose this connection and you cannot recover that. Before updating the address, just also store the next node address in some another variable, maybe temp3. You can keep like three variables, temp1, temp2, temp3, like this, and then update. So then update temp2 equal to temp1, like this. Okay, so the temp2 dot next equal to temp1. So this link will be connected like this and store null here. Now move your all your pointer one position okay, to the next position. Okay, so like this will become a temp1, this temp2, temp3. Okay. Now change the same thing here. So just store the reference of 20 node into the 30 next field, like this. So you need to update all the next field like this. Okay. So you will reach at this point and return the reference of this node as a return value of your function. Now your all connection is reverse and you are returning the reference of this node from the function. So once the traversing will happen from this node, and your output will come like 50, then 40, and then 30, and then 20 and 10. So your list will become a reverse.
Yes.
So
Okay, sir.
your task is just to reverse the reference of each node and return the reference of last node. This is your task. Okay, so I think you can maintain this with the help of three variables, and just always remember that before updating any things, okay, just keep maintain your data so that you should not lose anything during the process. Okay, like if suppose if we are not storing this that reference of this 30, and before that we have updated the reference of 20 to 10, then you cannot reach that 30 node because you don't have the address of this. That address was stored in the field of this 20 node that you have already changed. Then you cannot recover. Okay, so before updating anything, just make sure that you should not lose any information to for the further process. Okay, this is just like a swapping things. So if we have value a equal to 10 and b equal to 20, so how we can swap this? Okay, so in Python we can directly do, but in general, by the logic, we may use some temp variable. Okay, so like we store the temp equal to a first, then we store a equal to b, and then we store b equal to temp. Okay, so we are just using one additional variable to maintain. We don't want to lose the data, uh, and we are storing that as a temporary, for some temporary, and then we will use that later. Okay, and then we are maintaining that mode. Otherwise, what will happen if you have a equal to 10, b equal to 20, and what you are doing a equal to b. So same time you will lose the value of a. So now a become a 20 at this point. Now you cannot recover what was the value of a. So for b, that you cannot recover. Swapping. So same things we are doing here. So we are just using some additional variable to keep to store some data initially, so we can use that data and we don't want to lose some information. And our task is here only to update the next field to the previous field. So this is the only task. This is a grpa, so we cannot give much code details here, but logic I have already mentioned. This is the same logic you can think. Okay, yeah, Kancha.
Oh, yes, sir. I have a doubt. Sir, if we have a single node in a linked list and we want to delete that node, we know that if we take two pointers, head and tail, we know that the same node will be head and tail as well. So for
Hmm.
deleting that node, should we make both head is equal to tail is equal to none, or
None,
we
yeah,
could make it
none.
none?
Yes, this is you are saying if you are maintaining a list where you are also maintaining a tail. Okay, so and you have only one list, one elements. If you want to delete
Yes.
this, definitely both should become none after updating this. So these are some additional steps to take care for the operations. If you are maintaining tails and head both things, so at the time of deletion, if only one node is remaining, so at that time both values would be updated by none. Otherwise, if you are deleting last node, suppose, so only the tail value will be changed. Head value will not be changed. Suppose if you have more element head, okay, like this is the first, this is the second, third, like this, and this is tail, like this. Okay, this is the tail. If you want to delete this, so only tail will be updated. Tail should be updated to this one. Head will not be changed. But when the after deleting multiple elements, only one element is remaining, so at that time both should be updated.
Sir, if we like delete anyone, like if we make head is equal to none, then automatically tail would also be none, I guess.
No, so there is no actually free memory type of operation. So what will happen, you will lose the like head reference. So if you are making head equal to none here, so this connection will be removed. Still you can access your data from tail with the help of tail. That
Oh,
node still will be stored, and that you have the reference of that node inside the tail, then you can access that. But logically this should not happen. If you have deleted here, if we are deleting something, so that means we are removing all the reference of that. We cannot reach that.
yes.
Okay. Hmm. So from the linked list part, when you are performing these operations, so you should aware of that, how much effort you are doing to perform these operations and what should be the complexity. I think I have covered many of the operations complexity in activity assignments. So you will understand that how the effort is going on. Suppose if I see, if we have the structure like this head, and we have some element in the linked list, and so I'm just asking to you, just tell me the answer. Okay. So you as mentioned that we are also maintaining a tail. Okay. And that is referring to the last node. This is the last node. And we have this direction. Okay. Because each node containing the reference of next node, like this. Now suppose if we want to delete the last node from the list. So how you will delete this, and what would be the time complexity for this?
So we could do tail is equal to none, and the time complexity will be order of one.
It cannot be done.
No, it
You
can't be
need a
done.
previous
Cannot be
reference.
done.
Yeah,
Because the previous node has to be the
still
reference to
it
be
is
none.
pointing to the
The
last
moment we
node.
delete tail.
So means first thing, if you are performing some operation on any given structure, okay, so structure may be like singly linked list with a head node only. It may be singly linked list with head and tail. So first thing is understand the structure of your structure linked list. Okay, what data is given after any operation which you are performing, inserting at first node, middle, last node, deleting from the first, middle, last, your structure should remain maintained. What structure you have as input, that should remain maintained. Okay, so here if you are deleting this node, then what should be the updated structure? That means after deleting this node, the second last node should be become last node. Okay, so
Tail.
that means tail. So and also the next field should be updated by none value, and this tail should be pointed to this second last node. This is the updated structure after your delete operation. So how you will maintain this when you're performing the operations? So you cannot delete in constant time this, because you have the reference of last node, you have the reference of first node directly. But how you can identify the second last node address? You cannot identify the second last node address from the last node, because last node not contain the reference of previous node. So to get the reference of second last node, you have to come from this side one by one. Then you can reach at this second last to update this field, and also update your tail value to this second last node. So you have to perform all n widget like n operation. So complexity will be order of n.
So you have to check temp dot next not equal to none.
No, how you can check? Tail dot next is referring to this side, not the previous side, na? To delete, if you want to delete the last node, how you
Yeah,
can
I'm
get
saying
the
temp not tail.
so we have to traverse this list from the first node, then second, then third, like this. We have to one by one traverse, and we have to reach at the second last node. Okay, so in this way you have to perform this operation. So do not directly conclude any things just by looking. You have tail, you can directly perform. Okay, insert operation you can do at the last position with the help of tail in constant time, because at that time you need to update only last node next field or tail. Okay, so you can just connect like this and just update your tail to this, and this new node will be added by none.
So if
So
you
this
have tail,
operation
it's just order of one, no?
if you have tail, you can insert the new node at the last position in constant time, but you cannot delete the last node in constant time. Okay, in this structure, if you don't have tail, then delete and insert all operation will be performed in order of n time, because every time you have to traverse the list. You cannot directly identify the last node address. Okay, so always if you have any question with the linked list regarding this time, effort, all this complexity, just understand the structure first, what information is given to you. After operation, you should maintain the structure. So to maintain the structure, what update is required in the nodes or each field, just identify that, how you will update that, and what effort is required for that. Okay, then conclude the answer. Okay, so doubly linked list we are not covering in this course, but still you should know that is a small update is required only. Each node has three field. Okay, that is the only small change. You can simply implement it if you know how to implement singly linked list. Singly linked list contain two field, data and next. Doubly linked list contain three field, data, next, and previous. So each node will contain the reference of next and previous node. So at the time of creation just fulfill all the fields when you are performing any operation. So this structure should be maintained, like head if you have in doubly linked list. So each time each node has this three field. So that should fulfill when you are performing any operation. Okay. Suppose this is a last node, there is no first initial node, and suppose this is a tail. Okay. In this structure, you can delete the last node in constant time, because here you have the address, you have the last node, that reference is stored in tail, and you can also identify the second last node because that address is stored in previous field of the node. Okay, so you can directly identify the second last node. So this is the second last node, and then you can directly update this value as a none, and you can directly update this tail equal to this, and then you can remove this. Okay, so this will be disconnect. Okay, here because we have each node contains the previous node address, so we can directly identify that second last. So these are some small modification in doubly linked list. There are also another version. We have circular singly linked list, circular doubly linked list. So that are not covered here, but you can explore that. Circular singly linked list. So last node next field contain the reference of first node. Then it become a circular singly linked list. The same thing, doubly circular linked list. Last node contain the reference of first node, and first node previous field contain the reference of last node. Then it become a doubly circular linked list. So logically connections, how the connections are happening, we are just making the different type of lists. Okay.
Yes, sir.
Hmm.
So, uh,
Yeah.
um, so when we want to insert a new node at the beginning, then um, so we
Which
give the,
singly linked list or doubly you are talking?
um,
This is the singly type of
for
structure.
single one. So if we want to add the new node to the beginning, then we can do the new node dot next is equal to the self dot head. No, then the self dot
Uh-huh.
head is resembling memory address, right? The
Yes,
address
yes,
of the
correct.
node.
So new node dot next equal to head or self dot head. What implementation you have previously, how you are
Yeah,
storing, you can simply assign, and then you then make head self dot head equal to new.
yeah. So that is not the doubt. So in this case, this self dot head is a node object that is resembling memory, right? But when we are
So
when,
actually, as I mentioned, here we are talking about logically or conceptually. Okay, so do not target some particular implementation. I think you are targeting that recursive implementation, which is
no, I'm
so
not
how you are using self dot.
sorry.
Why you are using self dot head?
Uh,
How you assume that this is a object or anything? This is a self dot head. I have not mentioned anywhere. This is a self dot head. You can simply make a variable like head. Okay, head equal to, and that uh, class node. Okay, so link list. In another implementation, we have just created. Uh, so link list. This is recursive implementation. Here, yeah, self dot head is required. Okay, because self here also self dot head is not required. Okay, so this implementation, this is also not required. But in this implementation, you can see we are maintaining one link list. This is a one class. At the time of link list, we just started as L, or you can mention here head equal to link list object. Okay, and in this linked list object we have created linked list object. Now we are maintaining this self here. So I think linked list and self dot head. I think you are referring to this one, correct? Self
yeah.
dot head.
So
Huh.
to check it's empty or not, we are checking self dot head is equal to none. So just checking the
So you
data.
can
No?
that corner case you can check. That is all. I have just mentioned the like main concept of the operation, but yeah, these are some case you always check first if your linked list is already empty. If it is not empty, then do your task. Okay, so if self dot head is equal to none, that means no node is connected. Okay, so yeah, that is self dot head. You are referring to by some particular implementation like this, but conceptually we just use the term head. Head means that is referring to the first node. You can give first, you can give any name, first, last, anything. But the meaning is same. So that means the variable that contains the reference of first node, the one variable that contains the reference of last node. Naming you can change, but meaning should remain same. Okay, so self dot head, yeah, as per that implementation. So if you want to check that your list contain any elements or not, yeah, you can check by this if head equal to none. Okay, so in that way you can identify that your list contain any element or not. Okay, so suppose if you have any number of elements in the list and one by one you are deleting all the elements, like this element, then it will be delete, then it will be delete, and then it will be delete. So at the time of delete operation, if one element is remaining, then at that time we will update our head equal to none. So this is just like a structure we should fulfill correctly. So if our all elements are deleted, head should store none. Okay, so that if we check again, so if head equal to none, then we will identify that list is empty. Okay. We are also releasing some implementation video. If you are facing difficulty in the implementation part, I think I'm not sure you are aware of that or not. This time we are releasing some additional videos also. Uh, Phrase, you can see where are these videos?
Sir, it is in the last of each week.
This one, week 3 algorithm implementation. We are adding these implementation video. So you can see step by step these. So linked list part one, linked list part two. So see how the implementations are happening step by step. Just understand the implementation. Do not try to learn any particular implementation. Otherwise, you can definitely not remember. So just understand the idea of implementation, understand the concept, then try to implement by your own. Otherwise, always when you will see different implementation, definitely you will stuck at that one. How this implementation is happening, different implementation. So conceptually, all are doing the same things, but maybe some different type of styling of code. So just try to learn easy code which you can easily understand. If you are facing difficulty to understand recursive code, try to implement iteratively. Okay, so that is not compulsion like always implementing recursively. Okay, any other query, anyone? Any other doubt? Or in any week like week 2, week 3? Can you please explain what asymptotic worst case running time means? Okay, week 2. I think we have already given the detailed session for that. If okay, so worst case asymptotic means we are just looking the time, and that time is actually not the actual time. Okay, so we are not focusing on the actual all counts, all steps. First thing is what is this time represent actually. Okay, so I am just repeating again what this time complexity and what time is actually representing here. This is actually a theoretical topic, theoretical concept, and we are not calculating the clock time here. Okay, we are calculating the number of steps which are running at the runtime. Okay, number of steps are performing at the runtime by the algorithm. So that we are evaluating in the terms of input size. Okay, so this is just like a time complexity meaning here. So suppose if you have one code like for, and you are running a loop like, okay, so for I equal to 0 to n, this n variable is here. Okay, this n variable is here, and you are performing some task here, a one step. Just assume that this is a one step, any one step. So this loop you have here, this is the input value for this program, and how your loop total number of steps will change or will grow. Okay, so how your total number of steps will grow based on the input grow. So let's, if input is like 10, n equal to 10, how many times these steps will execute? 10 times, correct? If n become 100, so this will also become 100, correct? If n equal to 1000, then it will also become a 1000. So this is just like a simple linear grow. Okay, so this is side n, and this is type total of steps. Okay, so if you are increasing the input side, how your total steps are growing. So this is called as a linear type. And similarly, suppose if you have two nested loop, and for I equal to 0 to n, okay, this loop is first, and then second loop for j equal to 0 to n, and then you are performing some step, one step. Okay, now here how the steps are growing. Okay, if n equal to 10, how many times this step will perform?
10 into 10.
10 into 10, correct? So for each value of I, 10 times this loop will run. Okay, then second value 10 times, so total 10 into 10 means 100. Okay, if n equal to like 100, so this will become a 100 into 100, 10,000. So your this is growing with the rate of n square. Okay, if you are giving any value of n, that your steps are growing with this rate. So your asymptotic time is represented this relationship actually with the maximum magnitude. Okay, so this is just growing rate, how your steps are growing if your input is growing. Okay, so this is represented as a time complexity. Okay, worst case means, worst asymptotic time means when your algorithm takes the maximum time for any particular, okay, maximum possible time. So simple example you can understand that if you are searching something elements, you have some random element like 10, 20, 1, 3, 5, 6, 8, okay, 4. So suppose if you are searching any elements, element like 10, you will start your process simple basic naive approach. Simple compare the element one by one and identify that your element is exist or not. If you are looking for 10 element for searching, okay, so at first comparison you will see, yeah, this element is exist. Only one comparison is required and you will get your result in these steps. But same time if you are searching 4, at that time you will perform the same logic, okay, by the algorithm. So one by one if you will check, compare with the first, second, third, fourth, fifth, sixth, seven, and last. At that time the same algorithm which you applied at the first case, that become a best case with minimum time, and the same algorithm is now taking the maximum number of comparison, that is just like a worst case. Okay, so algorithms when takes the maximum possible time, that become a worst case for that. Okay, so we represent this time complexity in these terms. Exact number of steps count is called as a function. Okay, fn equal to that exact, if we count the exact number of steps by your code, so that become like n square plus 3n plus 2. You will get this type of function like this, okay, if you add all the steps. Okay, but to represent the growth of number of steps based on the input, we are always interested in the highest magnitude of n, this. Okay, and we ignore the this remaining part, which is not affecting too much if your input is very large. So we ignore the remaining part or constant part. We only check the highest magnitude of n as a complexity, and we represent with this some notations. So their notations are big O, omega, and theta. So we have discussed the rules for that. When we use this big O represent the upper bound, this is represent the lower bound, this is represent tightly bound. Upper bound means if you can identify that, so your algorithm will take maximum that much amount of the time in any possible case. So then you can represent with the big O n. If you have information that your algorithm will take this much amount of time in best possible case, and that if you have that information, you can represent the complexity with omega. If you have this information, like if your algorithm will always take this much amount of time either in worst case or best case, so then you can represent your complexity with theta. Okay, so generally we are using this big O notations because we want to reduce our worst case time. Okay, so to become our algorithm efficient, so we use mostly this big O notation with the complexity like this. Okay, so just see this, we have explained these all part in very detailed in week 2 live session, open session, to understand this, how what is the condition to use these notations. Otherwise these are the meaning of
So,
aesthetic. Yeah.
sir, my confusion is in the linked list part. Like, we can very easily make O of n complexity into O of 1 just by keeping in account the tail of the linked list. Like whenever we are appending, we if we know the tail, then we can directly append it at the end of the
Yes.
list.
Yeah.
So in this case, the complexity will change, right?
Complexity.
Worst case complexity will
Huh.
change.
So worst case is a situation, like, okay, situation when your algorithm is taking maximum amount of time. So like this is one operation which you are talking. So for this operation, what is the possibility of possible case? What you are doing, you have one list, okay, and like this. So you are actually change the structure. So you cannot consider that as a best case or something, because you change the structure head, and now you make the tail also. Okay, and previously when tail was not there, to that structure input was totally different. Okay, at that time, to perform this operation to insert a new node at the last point, your task was order of n. Okay, can you do this for this the same structure? Can you do the same task in or any efficient way? No. Okay, so means for the same algorithm, same input structure, is there a different behavior of the algorithm? So in this case, this behavior is same for all possibilities. So you have only this operation insert at a last position, this single operation. For this operation, your algorithm will always take order of n. So there is no case here actually, best or worst for this operation. Now
So,
you. Hmm.
in case we know the tail, can't we just append it as per the tail we know?
Now
Because
you change the structure. Now if you make the different input structure, now your problem become totally different. So tail, if you are adding tail, okay, so tail, if you're writing any algorithm for this, this best case, worst case are the things when the same algorithm takes the different amount of time for different possible input. Okay, but here now you are making the one algorithm for that with the head. tail, you can directly add one element at the last in constant time. Correct? So you are doing
Yes.
some process for that. So the same algorithm will always take order of n time. If you are making the one algorithm which are using the tail information and adding this, so that will always take one time. So this best case, worst case is not for always exist for this type of operation. There is only one operation you are doing, one structure you are following. The always you will get a constant time. Yeah, like for sorting example. Okay, so like you have already seen insertion sort algorithm.
Yes, sir.
Okay, so now insertion sort code is written like a fixed code. Now same code, if you are running on this input 1 2 3 4 5 6 like this input, now your steps actually will be performed less steps, only 8 steps. Now same algorithm you are giving on this input 6 5 4 3 2 1, then your steps will become totally different square. We are not changing algorithm. This is the input types. We are only changing the order. This is actually purpose of the algorithm, sort the input list. But by suppose if input is coming in mostly sorted, okay, so at that time the algorithm behavior is different. That will not perform your complete task, okay, and you will get a sorted output. Here this is the different possible input for the same algorithm. Now your algorithm will perform all the steps maximum possible time. The same algorithm we are using, but for different input, our time is changed. So that is just called like this is a best case possible time for the same algorithm. This is the worst possible time for any input. Okay, we are not changing algorithm here.
So just by putting a tail, we can convert it into the best case possible in the linked list. Is
Then you are changing the algorithm now.
uh,
You are
s-
so by for this structure you are improving your time efficiency for this operation. But here all things are changing. Actually, you are changing the linked list structure. After changing the linked list structure, you are also changing the algorithm. This best case and worst case considered for the same algorithm. We are not changing the algorithm. Okay, so that means what algorithm you have written. So that inserting at the last node, you have written like a suppose if you have this structure head and you are just traversing all node one by one from this side when you don't have the tail. So algorithm you have written is different algorithms. Suppose if you add this tail, still you are using the same algorithm. That algorithm still take same time. Okay, but you after changing this structure, you have also changed the algorithm steps to use this tail, and that you are changing the algorithm actually. Yeah, you are just improving the your operation efficiency, but by changing the structure. So that is not considered like as a best case or worst case. Best case and worst case are considered if you are not changing the algorithm, you are using the same algorithm.
so in this
But
case, asymptotic
so
worst case.
do not use the best case or worst case situation here. You are improving the code efficiency by changing the structure or algorithm. Okay, so do not use the best case here like this for this. This is not a best case you are talking about. Okay, so as I mentioned that best case, worst case consider if we are using the same algorithm without changing anything. If you are getting different behavior for different input, that then best case and worst case comes. If you are totally changing the algorithm, you cannot compare those.
Okay, sir.
Hmm. Yeah, so there are multiple ways. So what you can compare here. So suppose if you have tail, okay, and you want to insert. So for this structure, there are two different algorithms. There are two different algorithms. First algorithm we can apply, we can traverse all the elements, and then we can insert at the end. So that is algorithm one. Okay, that is different steps. And the same input structure we have algorithm two, that is directly using tail structure and directly performing. So this algorithm is taking n time. This algorithm is taking one time, order of one, order of one. So these are two different algorithms. Now you can, if you compare two different algorithms, so this is efficient algorithm we can take. We can say, okay. So this is the comparison of two different algorithms we can talk here. Okay. So one algorithm is efficient compared to the other algorithm for this structure. So same task we can do by two different approach, but this one is the efficient. So we will use this term here. Not, we will not say this is the best case for. But for this algorithm, this algorithm for this structure, this is the only one possible case. We cannot improve more than this by this algorithm A2. But
Um,
if you are comparing with the different algorithm, so this is efficient algorithm. Okay, A1, A2, and this is taking more time. Yes, someone talks in between.
Sir, why quicksort is faster than merge? Uh, quicksort has the order of n square, no? In worst case.
So why this is faster? You are saying quicksort is not faster.
In the
So
lecture, sir.
merge sort, uh, sort and quick sort. Okay, I'm just talking about the basic version of these algorithms. So merge sort always take order of n log n. Doesn't matter what type of input you are passing to this. So that means, not, no, best case, if suppose what we are considering, that if you are passing sorted list to this 1 2 3 4 5 6, doesn't matter what type of order you are giving to this merge sort, this will always perform these number of steps and log in. Okay, but for quick sort we have different, like n log n in worst case, n log n in average case, and n square is worst case.
We have to compare only worst case, no?
So in worst case, you can see here, in worst case, quick sort is actually slower. Slower means taking more time, n square, and this merge sort is faster. But remaining case, like the all case, like best case, when you are getting the best possible input for this quick sort, that time is same. Same if you compare the insertion sort, so that takes n, n square, and n square. Okay, so this n is the best case. So in best case, insertion sort is better to the merge sort and quick sort. Okay, because here n log n log n is there, but insertion sort takes n time. In best case, best case is here for 1 2 3 4 5 if you're passing sorted list. So this case is also different based on the algorithms. So here is best case is when it is taking minimum time. This is sorted list if you're passing sorted. Okay, what is the worst case for insertion sort? If you are passing reverse list. Okay, so like uh, 3 5 4 3 2 1, that is the worst possible case. Quick sort, what is the worst case? So if you are passing 1 2 3 4 5 6, still this will perform as a worst case for quick sort.
Wrong pivot selection also.
So what will happen if you are, suppose if your algorithm is taking first element as a pivot, so at every time you will traverse all the elements, and will you will get first element is coming at the first place. So that means in n steps you perform one, and your pivot is coming at the corner. And next step you will perform the same task on n minus 1 elements. Okay, so initially first was n, second steps you will perform the same task on the n minus 1. Then again, select pivot select element will come at the first position, because after pivot selection you perform comparison and you shift all the smaller element to the before the pivot and greater element after the pivot. This is the process of partition process. Okay, so if you are giving this sorted list to the quick sort will behave like as a worst case for this. Okay, so here again n minus 2 steps you will perform, n minus 2, then n minus 3. In this way, if you will add all these steps, you will get a n square complexity. Okay, so for quick sort, what is best case? For quick sort, best case is when your pivot element is always coming in between every partition process. Suppose if you are like passing for 1 3 or this is 4 1 3 2 and 6 mm, 5, like this. Suppose if you are getting, you are selecting this pivot element as a first element, and after partition process this will come here, and this 1 3 2 this will come like this, and 6 5 8 all greater element will come after this. So this is one step I have mentioned. If your pivot element is coming in between, and this happens on every call. Okay, next steps your quick sort will perform on this left part or right part. Again, the same things happen. Your pivot element is coming always in between. So at that time, your quick sort will take n log n steps. So that is the best case for quick sort. Okay, so we cannot say that always this sorted list is a best case for all sorting algorithms. So best case means when your algorithm is taking minimum time, and worst case means when algorithm is taking maximum possible time. The same algorithm we are talking about here, same algorithm, these cases are applicable on the same algorithm, and which are behaving differently on the different types of input. Okay, so we are not changing algorithm, we are not comparing two algorithm here, we are talking about same algorithm here. When we compare the two different approach, then we just compare like a which one is the efficient, means which one is taking less time. Okay, yeah, any other doubt? Any other doubt, anyone? Hmm.
Do you have any other sorting algorithm apart from this?
So we have seen selection sort, quick sort, insertion sort, merge sort. Later in week 6, we will see one more heap sort.
Heap sort.
Heap sort. Okay,
Okay.
once we will just learn tree, and after tree we will just see heap, and then we will see one more sorting algorithm, heap sort. One naive sorting algorithms is also there, bubble sort. You can just explore.
That is
That
that
that is
is
also
very
costly. Yeah, so order of n square. That is also costly algorithm.
that is useless. But there is one more counting sort that is better
There are
than.
many sorting algorithm, radix sort, counting sort, that we are not covering here. So you can explore those sorting algorithm also.
Yeah, but
So
quick sort is an efficient one, better than
which one?
counting. Counting,
Quick.
counting is better than quick.
So different types of input. Okay, so counting sort required some different types of input. Like okay, radix sort have some different type of input order. So different type of case we use different types of algorithms. So these are very common standard algorithms.
There was a PPI question based on counting sort.
No counting sort. Okay, so
Not
that
not directly.
I got
Counting
you are
sort.
just talking about that one dictionary. We just so counting sort is applicable when your most of the elements are duplicates. Then it is beneficial. Okay, so otherwise, if all elements are distinct, then how you will use beneficially use this counting sort? Okay, so that problems where we have repeated elements actually. So because of that, we are just in one single loop. We are getting the counting of each distinct elements. After that, we are just making a new. We are updating our input list based on the frequency of each distinct element. So that approach we are using on that PPA. Okay. So also we in week 2 we have released three more GRPA. If you have time, you can try those problems also, because that is also good problem where you can apply binary search logic and simple some efficient logic. So okay, if you have already solved GRPS, still you can try that also. Okay, we will only consider for those who have missed the first GRPA to fulfill OPP criteria. We will consider that GRP new GRPA only for those. Okay, so if you have already done, still you can also try. Okay. Any other query?
Sir, can you show how to visualize these algorithms?
Yeah, we have already added the visualizations in our notes actually. I don't know you have seen this. Each algorithm we have added the visualization.
Those are visualizations of these.
Visual algo. Visual
So,
algo is here. So here you can just open visualization and you can select the algorithm. So like this is third week. Second week, suppose if we are talking about the sorting algorithms. So each algorithm we have added this visualization, so you can just see how the operations are performed. Also, we have added the Python tutor, okay, where you can see step by step effect all on your data. Okay, so here you can also use this Python tutor, this step by step, how the list is updating by each steps. Okay, so you can utilize this. Otherwise, you can also open visualization like selection sort, select the algorithm from here, and just sort the step by step. You can see you will get how the selection sort is works. So steps is also running here. So you can utilize this.
can you show for data structures also? How to
Data structure
visualize
means,
data
huh?
structures, linked list, and
Linked list is given here. Linked list. So, mm,
uh,
so you can see. Okay, you can see head, we are assuming this, tail, we are assuming this six. Okay, index by index. Then we are performing some insert operation, remove operation, search operation, or create operation. Okay, like search, what element you are searching, suppose. So we equal to just mention the element here. So like 43. So 43 you are go. Okay, now your algorithm, this is now searching algorithm. It will just compare element one by one and moving to the next. And now you will see it is matched here. So same all operation you can just
is
visualize.
it Java?
Huh? This is JavaScript. These are implemented by JavaScript. This
Um,
visualization is happening by JavaScript, but this code may be different. Okay, this is just like a pseudo code. This is not a Python code. This is a pseudo code. Okay, so this implementation, just so as I mentioned that if you will see implementation on different resource, you will always get some different type of styles of coding. Okay, so do not learn the code actually, just understand the code, understand the logic and implement by your own, then you can effectively learn. Okay, this is code, so step by step it is performing, but see how the steps are. Suppose if you're adding insert, okay, head, after, and like positions are mentioned, which position you want to insert, so you can just use these visual algo tools. Okay, so stack, queue, all are mentioned here. So how we can implement this stack and queue things. Okay, any other?
yes, sir.
No doubt.
Also, anything for practicing these questions, algorithm-based questions.
So practicing question we are also giving many like conceptual question like as a activity or GAPA programming. We are also giving many assignments. So that is enough, I think. If you will do all these things, assignments question, that is enough to for any like
Is it enough
exam.
for quizzes?
It is enough. If you will solve all these activity assignment and all
Mm.
related assignment, practice assignment, that is enough for your quiz. But thing is, for this type of course, understand the concepts. Okay, so questions may be little bit different types, but if you know the concepts, definitely you can solve. Okay, this is just not like a formula based thing, so you will learn a formula and solve that. This is not a math. This is totally conceptual course, logical course. Okay, anything else? Hashing deletion concept. Hashing is nothing when you are maintaining hash table in the list. Simply update the value by none. That is the delete things. Okay. Simply searching concept. You can just identify the index by your key, restart the index where your data is stored, update that value as a none. So that is just a delete operation. Retrieval is what? Retrieval is searching like thing. So okay, so if you are maintaining key value type of pairs, so definitely the same. Actually, hashing is just like a constant operation. So searching, insertion, deletion, everything happens in the constant time. So means every time you use the hash function to identify the address actually. Suppose you have the key. Suppose if you're searching the key in your hash table and you want to identify the value, what is the corresponding value, and key and value are stored at some memory location which is mapped by some index. Okay, in your hash table. So you can simply pass that key to the hash function. You will get an index. Just identify that index where your data is stored, and your key value is stored at in grouped manner. So you can just fetch your value, and you will get that data. Okay, so in constant time you will reach at your index by calculating the hash function. Okay, so same applies actually. Hash function is used to identify the index to store data and search data or remove data. So same hash function used. So but in this way you will get direct address or index to fetch the data. Because of that, this is a constant time operations we performed by the hashing or dictionary. Okay. Okay,
So,
so
can you please explain with the example? I'm not able to understand this.
so retrieval means what you want to do actually.
Retrieval means, if I'm not wrong, that after deletion, we are getting the value back, right?
Value back now. Okay, so suppose you want to maintain a dictionary type of data. Okay, so where k r and v, this type of data you want to maintain. So suppose we are using this key as a like key for hash function, and we want to store the value in our dictionary or hash tables or any place. So we maintain one hash table here. So hash table have fixed number of steps. So what memory, we are just taking some small count, but memory have very big. So 0, 1, 2, 3, 4, 5, 6, 7, 8, like this. Okay, or 9. Let's take 9. And this is just like a also mapped with some memory location. It may be mapped with memory location that contains the different value. So suppose we want to store like id and suppose name, this type of information. Id, unique id, and you know in dictionary key should be unique. Okay, value should be maybe same. But so this we are using as a key id. So this we will pass to the key hash function. Suppose that is id and reminder and some, what is the table size we have, that is 10. Okay, so suppose ID is equal to like 3 and name is like a Amit. We want to store this information in our record. So 3 we will pass this 3 reminder 10, so it will provide 3 as an index. So that means we will directly jump to this index. And here we will store our value. Here what we can do, we can directly store our value v here. Okay, so that means Amit. Or if you have more information, like if you have more data to store as the value, like if you want to store some list or something, so you can just refer to some other object and you can store directly that, like in the Amit. Okay, so that means you are storing the reference of some other object which contain the value. So in this way, now your data is stored. At the next time, so this the same things, if you want to search what is the value for 3 is stored. Okay, so what is the value for 3 key? So same, you will pass this key to the same hash function, so that will just calculate the same thing again and will identify 3 index, and that will directly jump to this location, and it will return this value from this. Okay, it will return this value value. So this operation means we are not traversing each index one by one. We are directly reaching to the index where our data is stored. So because of that, this is a constant time operation in dictionary. So we will directly get our data value. We are using key as a we are using ID as a key for hash function, but we are fetching our value which is stored at that location. So searching, like this storing, we use the same concept. At the time we store the data, but searching we use the same hash function, but we directly jump or fetch the data. So because of that, this all operation perform at constant time. Okay.
Okay, sir.
Hmm. I suppose if you want to delete something, so that we can completely remove the information, or we can just update this data by none, something like that. Means we are just resetting this location. Okay, so this will be removed.
So this index will just point to that location where the value is, or the value is directly stored at this.
So that is depends on how what type of data you are storing. Suppose as value you are storing, but some big data. So that, suppose if we are maintaining this hash table, generally this index is mapped with some object. That object is a different memory location where our main data is stored. So this is just like a mapping. Okay. So we
Yes.
use follow this approach. We not store data at this location because we don't know how much memory is required. So memory is allocated when you want to store the data. So suppose if you want to store this Amit, this is a small storing 10. So less memory is required to store this. So at the time when you are storing the data, at the time one new object will create based on your value, and that will be mapped to your that index reference. Okay, so that will store. If you want to store one big list as a value in dictionary, you can store any type of data as a value. So another object will be created and your complete list will be stored, but that will be mapped to your index ref, that reference. So in this way, you can store any type of data as a value.
So when we are deleting the value, that means that we are just deleting the pointer to
Huh.
towards that
Yes. So
value,
some
right?
reference means some address is stored at this location. So that we will replace by none. So that means we remove this reference.
So
So
how
that
we will be able to retrieve that?
no. So how we can delete if we have delete something? So how we can retrieve this?
Sir, isn't retrieval means after deletion we can retrieve
So
the value?
that is the different totally logic that some backup should be there. But in program, suppose if you have deleted any data, so how you can recover that? In simple program, simple hash table, we if so some programming actually that maintains some backup recovery process, that is totally different area to learn. That is, you have to learn some database and that backup process, recovery process, log process, all the things actually you have to learn for that. That is totally different area. So some recovery techniques and some backup techniques is used to if you want to if you after deleting and you want to use some recovery things, so some recovery techniques is used internally. Okay, so just if we deleted some data from our computer, but later some recovery happens and we got the data. So some backup process is there. Some data is stored in raw format. Then some recovery tools are used to that generate the data again by with the help of some logs and all these details. But in simple program, if we have deleted some things, we cannot recover if our programming language or that not provided the features.
So it was just mentioned in the book itself. So I was just thinking like maybe it is possible in hash mapping. Uh, that operation is also
This retrieval is not a recovery. Okay, retrieval means fetch the data. Like okay, that retrieval is not a operation of recovery type of which you are talking about. Retrieval operation means if you want to get the data while searching, so that operation is called as a retrieval. Where from you
okay.
got this information? Retrieval is a recovery type of after deleting you are getting the data. Where it is
So
mentioned.
I was just confused. So I was just
So retrieval means you are fetching your data, which is already stored.
like
Okay,
we are
so
just searching for that
searching
particular.
data, yeah, just like dictionary.
Okay.
If we want to get the value, if it is already stored, then you are retrieval that value. So retrieval means is not here like as a you delete the data and recovery the data. That is different terms. Okay, that is used for like networking or this where we are storing the data centers. Some recovery mechanisms are there, so that are totally different things.
Okay, so thank you so much.
Okay. Okay. Anything else? So this Friday there is no session. So we will come. TA sessions are going on. So still you can join the TA session and ask your doubts and also uh, solve the big 3 lead code problems or activity assignment discuss with TA.
So,
Hmm.
what is the quiz one syllabus?
Week 1 to week 4.
1 to 4.
Hmm. Okay.
Thank you, sir.
Okay. Yeah. Thanks everyone. Bye.
Think so.
Okay.
Thank you, sir.
Yeah. Bye. Good night.